Hello, this is Greg Allison of Galactic Greg's coming to you from an unknown location somewhere in the Milky Way galaxy. On this very morning of the 22nd of December 2019, Boeing's commercial crew capsule, the Starliner CST-100, which has been dubbed now the Calypso this morning by its first commercial crew commander, Sunita Williams. More on that in a little bit, but fortunately this morning, the capsule Calypso landed safely in the desert of New Mexico at White Sands Missile Range, also known as Space Harbor in that particular part. It landed at 7:58 p.m. Eastern Standard Time, or 12:58 Greenwich Mean Time. And fortunately, the so-called flight dummy did not become a crash dummy. The Rosie, the Rocketeer, did return home safely with a cheer. Now, it is interesting to note that the capsule atmosphere was in good condition. The capsule made a very soft landing. And but the bad side was that it did not achieve the primary mission objective of docking with the International Space Station. The CST-100 Starliner of Boeing was launched on the Atlas V rocket on the 20th of December at 6:36 a.m. Eastern Standard Time, which is 11:36 Greenwich Mean Time. Now, the launch on the Atlas V went without any flaw at all, and it was the first time in a long time that the Centaur upper stage flew with two RL-10 rocket boosters. RL-10 is a very neat booster, and it is actually older than me, and it's flown very successfully. It is the only operational restartable liquid hydrogen engine we have for flight in deep space. On the Apollo program, the J2 engine was used for that, and there had been talk of doing a J2X engine, but even the Space Launch System is going with the RL-10. Now, turns out that SpaceX will be developing a set of Raptor engines, which should also be capable of achieving the same objective, but they don't use liquid hydrogen as a fuel, they use methane. So a little bit different. However, all that said, the launch, as I said, proceeded without flaw. However, when the Starliner was put on its own propulsion systems to reach the space station, it had a problem. It's clocked, according to the Senior Vice President for Boeing's Space and Launch Systems, Jim Charlton. I wonder if he writes Charlton manuals. He stated that the clock was started too early. We knew there was a clock glitch supposedly, but he said it was started too early. If the clock was started too early, the hardware of the clock might be fine. It is probably a software issue. Software issues are easier to fix in some regards, but software is a bit of a bugaboo sometimes in space flight and technical systems, because sometimes the testers are challenged to thoroughly test out all the operational branches of software, and apparently something fell through the cracks here. Something I have a lot of concern with in my day job, I might add. So that said, the booster did not meet the 250-mile orbit of the International Space Station because it burned too much fuel too early on. And because of that, it got to about 155-mile orbit. But it did make 33 orbits around the Earth. So it operated its systems. They did a lot of on-orbit checkouts. They claimed that they did get a good test of the thrusters. Well, I'd say maybe a little extra good. A little too much, a little too early on, it seems. But the Starliner, as we can see, had challenges in that regard. And unfortunately, when it was having this glitch that it was firing too much too early, they had a comm glitch with the Starliner. Mission Control tried to override the problems, but there was also this glitch with the satellite systems. The tracking data relay satellites known as TDRS don't provide absolute perfect coverage through orbit, through the entire orbit of the spacecraft. And this happened while they were in a glitch of coverage. It could have been a problem with the satellite itself also. I don't know exactly the physics this time, but as you may recall, the space shuttle did have comm glitches as it went around the Earth. The TDRS coverage was somewhat less than absolutely perfect. With good geosynchronous satellites sufficiently spaced, we should have 100% coverage, but that's not the case here. So that said, all the holes in the Swiss cheese lined up, and you had a problem. That's what happens when you have a failure: is the holes in the Swiss cheese lined up. One, the clock started too early. Two, you couldn't command override. Now, NASA and Boeing have said that if we had a crew on board, they could have fixed that potentially, and maybe they could have. And that is one of the values of crews, is that crews can do things that automated systems, as of this date, still fail to do. I mean, hey, just pick up your phone and call into a place and get the automated little AI answer system. Do you want this? Do you want that? And, you know, the options are never what you want, right? So AI is really artificial stupidity in my book so far. So it's still a long way from taking over the world. All that said, I like to have a little fun, guys. Come on. Space is so NASA has succeeded exceptionally well in making the grandest event of all history when we landed on the moon in 20 July of 1969. Absolutely boring situation, normal. We have touchdown. Come on, NASA. We're doing really exciting things here, so it pays to keep the audience a little bit lively and have a little fun. So, like I said, they did not manage to override the systems. It fell short. They did get a lot of other subsystem tests on orbit, and they're declaring it a partial success due to that. And indeed, they did get those things done. And from my knothole, hey, Rosette Riveter was not a crash dummy. That's a huge thing. They did make it down. They had a soft landing, which meant the crew could have survived this mission. That's very significant. And does that mean a crew flies on the next one? Well, they're not telling us that yet. They've not announced whether or not they will fly a crew on the next mission, as they originally would have had all these things were successful, potentially. But, you know, we shall see. I would tend to think that the way they've couched this, that they're really hoping they can turn it around and do just that and fly a crew to the International Space Station on the very next mission. You know, but we shall see. There will have to be reviews done for the safety of this glitch they had with the clock start and such things. So this comes on the heels of some other financial tragedies for Boeing, because as you may know, their 737 MAX aircraft fleet is grounded. They got something like, I think, 400 sitting on back order, just sitting around built at their plant. And it's been grounded for like over a year now, or getting close to it. Well, not quite yet a year, because they had two crashes. They had the crash in Indonesia in October of 2018, and they had the Ethiopian air crash in March of 2019. Then countries all over the world started shutting down the aircraft, including our American FAA. So their fleet is grounded, and they've got to get these problems fixed. So they're having financial problems. And with this latest event with the Boeing Starliner, it does not help them that they had an issue, an anomaly, whatever it may have been. So what happens next is they are going to have to go through their safety reviews, which Boeing had suggested might be as little as 3 months. I think that's very optimistic given NASA and reviews and what you might come into. But to give you some idea here, the cost, NASA is committed to paying Boeing something, and SpaceX, something on the order of $8 billion to launch 6 crews, or 6 missions with 4 crew members each, to the International Space Station by the year 2024. That's quite a bit, and the cost that's been by the NASA IG attributed per astronaut basis for these flights is from Boeing. They're figuring that it's like $90 million an astronaut per flight, which you know, is still a little higher than what we were paying the Russians, who were trying to get away from, at least it's American, right? We were paying the Russians $80 million a flight, and NASA IG estimated that SpaceX cost us $55 million a flight per astronaut, not per each mission. So when you look at it that way, you know, you think, well, SpaceX is coming in a lot better, a lot cheaper, and maybe they are, but you got to also recall that this cost includes the development cost of the Starliner CST-100, the development cost of the Dragon launch vehicle, and a lot of the Dragon costs were actually paid for by the commercial cargo program in which the basic Dragon systems were developed. As you may recall, Dragon actually did successfully dock with the ISS in March of this year, 2019, and I did do a video celebrating that docking. And unfortunately, since then, that very same spacecraft exploded during the test of its orbital abort system. which we've been doing a lot more tests of, and we'll do another test real soon of a launch abort. They will, I think they're on tap to try to fly a crew mission later in 2020. We shall see how that plays out. I'm not going to sit here and speculate on dates because there's still a lot of things to be worked out. So this is about a bit of a setback in the commercial crew program. Commercial crew is challenged by these things. We hope that we can see through all these challenges, but space is not easy. Space is difficult. I've always maintained that. Space is hard. And a space launch system and crew launch system, all these things are like a long chain. If any one link in this chain breaks, the whole mission can go awry. So you try to have redundancy and design margin and all these things built in when you can. But it happens right now that both Boeing and SpaceX are 2 years behind their schedule. So when you're looking to SpaceX and their Starship program with great optimism, you got to recall that they're 2 years behind on this seemingly smaller program, although a lot of that schedule demand has to do with parachute test and a lot of things the government expects of. But hey, SpaceX did blow up the Dragon capsule. The CST-100 didn't make the 250-mile high orbit. It had what we would call an abort to orbit. And then it came home safely after 3 days of flight instead of an 8-day mission they had hoped for. Well, I can't get my fingers warm right. I do it this way, yeah, 8 days. So it's challenging. And you may recall in some earlier videos I've done, I elucidated Allison's laws of rockets. And I felt like I have the right to do that since I was building and developing rockets in the 90s of my own to launch my altitude balloons, which I'll cover in a future video. I think I need to do a basic rockets 101 before I start going into the details about rocket systems and rocket motors. So I'll do that in the very near future. But my laws of rockets are: 1, rockets go boom. 2, rockets have always gone boom. 3, rockets always will go boom. Always. And I say that because rockets are highly energetic. You ask a lot of a system to be able to contain the forces, the pressures, the heat, and everything required in a rocket engine. And going to orbit requires putting considerably more energy into your body than going on a jet airplane trip across the country. So rocketry will never, ever, ever be as safe as getting on board an airliner like a Boeing 737 MAX. Well, and that thing, it was a control system problem. Again, that might have been software. Most likely was. We talked about software here a little bit. Now, maybe I should do a special program on software. In the case of the Boeing 737 MAX, it was a maneuvering characteristics augmentation system, maneuvering characteristics augmentation system, which they call MCAS, that gave them the problem. And it would cause the aircraft to nosedive. When it was trying to correct for compensating something else, it was misreading probably in the software system. So I would assume that's all software. It could have been sensor errors, but I would definitely think that's most likely a software issue that caused that. So Boeing is challenged financially right now. They are probably looking for help. And even the Atlas V that it flew on, it's not a Boeing spacecraft or launch vehicle. It's actually a launch vehicle of the United Launch Alliance, which was formed from a joint conglomeration of Boeing and Lockheed. They went together and formed the United Launch Alliance. So Boeing defers their launches to that. The earlier developed Boeing Delta IV, which also now launches under the United Launch Alliance, was not wanted to be used for launching the commercial crew program because it just didn't look good, because every time they launch the thing, it catches on fire, flames shoot up all around it. It hasn't affected the flight, but you know, when you got crew on board, it's a little bit scary proposition to consider you got flames licking up all around your booster stage. And it might be noted that one case where an orbital abort system was used effectively and saved the crew was on one of the Soyuz launches where they had to happen. And it just escaped from the booster before it exploded on pad. So that kind of thing does happen. It should be noted that the SpaceX spaceship does not have an abort system, as neither did the space shuttle. Didn't work out too well for that vehicle, did it? So I do hope that SpaceX will succeed with their spaceship concept, that Jeff Bezos has something interesting up his sleeve with the New Glenn And moreover, hopefully with the new Armstrong, which might be able to catch up with the capabilities that SpaceX intends to use with their spaceship, which I think New Glenn probably falls short of. I don't know, we shall see. It may be more reliable. We shall see that too, right? So I do wish them both success because they both have grand visions that could really enable our space exploration and development, space settlement ambitions. And that is very important for where we need to go as a species. All that said, the intermediate steps of what's right in front of us right now is commercial crew. And for that, once again, I do hope that Boeing will make the commercial crew's CST-100 Calypso vehicle successful. And I also hope that SpaceX will succeed with the Dragon capsule, and we will see no more anomalies. We'll see all the next flights to the ISS being 100% successful. So Nathan Williams, Sunny Williams, as she's known, is dubbed to be the commander of the very first flight of the Boeing CST-100 Starliner, which she has dubbed to be Calypso. Now, it is the tradition that astronauts get to name their spaceship, although I think it does have to go through a formal approval channels. Calypso, she took that name, of course, from the sailing ship, or I should say the exploration ship of Jacques Cousteau. She's an avid diver, and she really believes in taking care of the Earth's ocean, so I can see where she would come from with the name Calypso. Now, Calypso also is an interesting name, as Calypso was the name of the nymph that held Odysseus for 7 years in captivity in the Odyssey. So maybe this new Calypso capsule will take us on a space odyssey. That's kind of interesting. Yeah, I was a member of the Cousteau Society way back in the 70s, and one of my good friends, the late Frederick Ordway III, was the science director for the Space Odyssey, 2010, A Space Odyssey, a movie produced by Stanley Kubrick. Very interesting. So I do like that is a name for a spaceship, although I don't know if it will sell through or not. Also, Calypso's name of a Corvette class of sailing ships way back in the days of old. So it's a name that's got quite a bit of history to it. So we shall see where the Calypso shall go. And I might add, Sunny Williams' father was actually from India, and her mother was from Slovenia. The Indian people have a lot to be proud of with space development. They're one of the most enthusiastic space countries I've seen. The people from India really amaze me, how much they love, how much they're interested in space. So that's just one more thing for you to be proud of. And also we might note that Sunny Williams had at one time held the record for spacewalk hours. She was like 50 hours and 40 minutes in spacewalks. She's flown on ISS several times, and hopefully she will retain that record after returning to ISS. Given what we see and have seen with the explosion of the very first SpaceX Dragon capsule, and with the failure to achieve space station orbit of Boeing's CST-100 Starliner, that commercial crew is very challenging. It's not trivial. The things that have to be done to reach space is, as I have said, very difficult. Also, what's coming up, the things that we're really looking forward to seeing, I would hope, would be the SpaceX Starship, what it can accomplish, and the new Glenn and hopefully a new Armstrong from Blue Origin. All that said, there are many challenges. I did a video on that recently. Look at this video here, which y'all were talking about the Starship strengths and weaknesses, and consider that it's no small order, given Allison's laws of rockets, for what you have to do and what can go wrong, especially when you're doing so many new technological steps all at once. It's a big risk. We call that technological readiness level, TRL. The TRL for Starliner right now is low. But what I have the confidence in an approach like SpaceX that you couldn't have with bigger political driven organizations such as NASA is their tenacity. Elon Musk pretty had the tenacity when he crashed and blew up several boosters on the decks of boats and upon return, and he just kept at it until he nailed it and he got it right. He wasn't afraid of having failure. So they can afford failure. As long as they don't blow up Boca Chica, for Pete's sakes. I did a video on that too, and you should pay heed. Citizens of Boca Chica, residents thereof, full-blown Starliner Starship, excuse me, will have about twice the fuel of a Saturn V or a Russian N1. And the Russian N1, when it blew up on launch, threw debris 6 miles, and you're only 2 miles on launch pad, my friends. So see my video on that. Will SpaceX nuke Boca Chica? Well, I hope not. I definitely hope not, and I do hope the spaceship will fly and fly very successfully with a good rate, and not exceedingly seldom invoke Allison's laws of rockets. After all, there's our job, to make them go boom less often. And maybe one day we'll come up with some other technology which will be better than rockets. My oldest videos were on subjects suggestive of that. So, okay, so we're on the ground. We're going to determine where we go next. Will the Starliner fly again with crew, or will it be uncrewed? I don't know, but stay tuned to find out. If you've not subscribed to my channel, please subscribe. You can support my channel by clicking links below that were really set up for my sister channel, Green Greg's, in which I cover growing things, prepping, and how to survive, thrive, and stay out of the hive kind of topics. A little bit different genre and direction as this channel, which is totally assuming we've got a bright, prosperous future, and which is what I really hope for. So, ladies and gentlemen, I thank you for watching, and happy holidays. For that.